Hi everyone, hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So in this video, in continuation to the video for Introduction to Database Management Systems, we are next going to talk about users, right? So when we talk about DBMS as a system, what all users are available for that system or that software, okay? So let's talk about that. The first is database administrator. Now, a database administrator, in short also known as a DBA, is the one who manages the complete database management system. He or she takes care of the security of the DBMS, its availability, managing the licensing keys, managing user accounts and access, etc. So that person, DBA, does not really do a lot of things on the data, okay, what is you're actually storing inside it. He or she mostly takes care of everything about the administration of the data, okay. For example, you want to make sure that the system is always available, it's never down. You want to make sure that who all have the license available for accessing that database, which are organizations. How do you access manage user accounts, which all user has which kind of permission and access available. So a database administrator or a DBA basically takes care of all these things, okay. Next comes over here the application programmer or software developer. Now this user group is involved in developing and designing the parts of the DBMS, right? So this DBMS in the end is a software, right? Someone is going to build it, someone is going to create that software, right? Someone's going to have to take care of the fact that it is working fine, right? All the components of the DBMS systems are absolutely correct and it suffices the user's use case as well. So a software developer who is involved in creating and designing and working on the development of the DBMS system is known as application programmer or software developer. For example, Oracle has this one major product for designing DBMS, right? So they have a certain set of developers known as application programmer who works on building more features for their DBMS system, okay. And the third kind of user here is the end user, right? These days, all modern applications, web or mobile, basically stores data, correct? Now, how do you think they do it? Yes, the applications are programmed in such a way that they collect the user data and store the data on the DBMS systems running on their servers. So end users are the one who actually store, retrieve, update and delete the data. Think of user as someone as you, right, who's actually using the database systems, correct? You are the end user. The database systems which companies like IBM, Oracle are working on, it's for you guys, right? You are the ones who's actually going to use it. You are the ones who's actually going to store it, retrieve it, update the data, delete the data, right? So whenever, let's say you're using any web application, right, or using your mobile or anything like that, right, you have some data, you are generating some kind of data, right? All of it is basically stored in the DBMS systems for that particular website's web server on their SQL servers, right? So they're storing all your information on their DBMS systems, which is running on their own server, correct? And the end users are the one who's actually accessing that information. All right. So these basically makes up the three kind of users which we have available. Just to quickly reiterate, first we have the database administrators, right? They are the ones who manages the complete database management systems. They take care of the security, its availability, managing the license keys, managing the user accounts, managing the accesses, who all have the access. They don't really work on the data itself. They work on the administration of the DBMS. Then the application programmer or the software developer, which actually is involved in designing and developing the entire DBMS software that you work on. And third is the end user, the people who are actually using those DBMS systems to store, retrieve, update and delete the data, right? And everything is designed in such a way that if you're accessing some website, if you're accessing some modern application, when you submit some data, let's say you log in, right, or you sign up, you give in your some details, all of that is stored on that website's DBMS systems which are running on the server, okay? So we basically store all that information. Now let's talk about the architecture, right? Now, what happens is a database management system is not always directly available for users and applications to access and store data, right? It's not always the case that you have a database management system, you install it and you just directly start using it and start manipulating data on top of it, right? That's not always the scenario. A database management system can be centralized. That means all the data is, let's say, stored at a particular location, right? For example, I install the DBMS software in my computer, right? And I store all the information in that computer, in that software. So all of it is centralized. All the information is basically present in a particular location. That's one kind of way of doing this. The other kind of way of doing this is decentralization, right? So you have a database that is stored, you put some information in it, but the copies of it, the database, are stored at different locations all over the world. Or it could be hierarchical as well, depending on the architecture. So let's say the main information you're storing somewhere and everything is stored in a hierarchical tree kind of a structure. Okay. So two things over here. First, it's not like you always directly access the database system softwares, right? Sometimes there are layers in between, right? The second thing being that the information could be all in one place, let's say in a certain computer, or it could be decentralized. That means at multiple locations, multiple copies of the databases are available, or it could be hierarchical in nature based upon the architecture and the type of information that you have to store. So in this video, we are going to take a look at the architecture for that. The first is the tier 1 DBMS architecture, right? This is the one that also exists. This is where the first situation happens, where the database is directly available to the user for it to store data. Let's say if I take my computer, I install DBMS software on it and I am directly accessing the database and storing and manipulating the DBMS system. That's what tier 1 architecture is, right? Generally, a setup is used for local application development where programmer communicates directly with the database for quick communication. All right. So that is tier 1 DBMS architecture. Okay. I'm the user. This is my computer. I install the DBMS software. I am directly writing queries in the database and accessing it. That being tier 1. That means there's no literally layer in between the user and the database. Tier 2 architecture. Now, in what happens in tier 2 architecture, it includes an application layer between the user and the database, okay, which is responsible to communicate the user's request to the database management system and then sends the response from the DBMS to the user. It looks something like this. So you have the DBMS, you have the user or a client, and you have the application layer. Okay, so there's like a layer in between, the application layer. So this is tier 2. Okay, that's for example, think of it a way there where, let's say, you are going to a website, right? And you have some kind of information that you want to store, but there's like an application, a website in between, which gives you and fetches the information. So that application, right, which you are using is basically like a interface, right? That's a layer in between, because you're not able to directly query the database. If you need some information, you have to maybe click some buttons or use the interface to be able to actually make your information communicate to the application, and then application basically makes communication to the database to basically fetch your details. So this is like an API call over here, right? As a user, when I communicate a request, when I click on some button, I am effectively making an API call, okay? And because of which the information is getting communicated to the database systems, which is on the other end, okay? Here it says an application interface, basically known as ODBC, Open Database Connectivity, provides an API that allows client-side program to call the DBMS, okay? So here I basically interact with the ODBC only. It's kind of like that, okay, where I am making a communication with that, right? The ODBC provides me, like I told you, right, some APIs, right, which I can use, make a call on that APIs and then call the DBMS. So in that case, you don't really have to write the query, okay? You just make the API call and the API call automatically converts the call into a query language command, which gets converted into what the DBMS basically understands, okay? So, like it says, an application interface known as ODBC provides an API that allows client program to call the DBMS. Most DBMS vendors provide ODBC drivers for their DBMS. So it's something like this. So if you have your DBMS systems over here, right, you have in between a layer known as application layer, right, which basically provides you a set of API calls. Let's say this is for create a table. Let's say this is for delete. Okay, this is for, let's say, manipulation of anything that you want to do, right? So you make this API call, right? This API call basically does what it has to do for the database. So most companies which basically makes database management systems, they make these ODBC drivers as well to make it easily accessible for the applications. All right. So remember that if there's a company like Oracle which is making a database management system, they are bound to make the ODBC drivers as well, because they want to provide the flexibility for having a two-tier architecture and not always direct access to the databases. Now, such an architecture provides the DBMS extra security, okay, as it is not exposed to end user directly. Now, think of it this way. I want people to be able to create a table, right? And I want people to be able to access a table, okay? But I don't want them to be able to delete a table. So ODBC drivers are a very good way for doing that, because if you will not provide an API for deleting a table, the end user will not actually be able to delete the table. But if you were following the tier 1 architecture, there the user has direct access to the database and he or she can just write the query and do whatever they want with the database, right? But here when you introduce a layer in between, a ODBC layer in between, what happens is now the user only have access to those functionalities with which the drivers provide. Okay, and if you want limited functionality and options to be available, you provide limited API calls. Okay, so that's what very important is, and that's what promotes security as well, because we do not expose the system directly to the end user. Okay, also security can actually be improved by adding security and authentication checks in the application layer as well. So what we do is in the application layer, not just these drivers, but what you can also do is you can also introduce another layer of authentication. Okay, where you don't want the user to directly access even the API calls. Let's say even for this application layer, I want to provide limited access. So the users who are authenticated and who have actually been provided the access are the ones who will actually be able to manipulate the database as well. So just to provide even one level more of security, you can introduce authentication as well. Okay. Authentication, or like it says over here, you can add security as well. Let's say the person has to, provide some more level of, let's say, answer a security question or anything like that's just a very simple example that they have to do in order to be able to actually get authenticated. Okay. All right. So this basically forms our two-tier DBMS architecture. And here are the diagrams for that. The third one is three-tier DBMS architecture. Now, in a three-tier DBMS architecture is the most commonly used architecture these days for web applications. Now, it is an extension of the two-tier architecture. In the two-tier architecture, we have an application layer which can be accessed programmatically, right, to basically perform various operations in the DBMS. This we've already seen. Now, the application layer generally understands the database access language and provides end users request to the DBMS, and it basically processes the end users request to the DBMS. In the three-tier architecture, an additional presentation or GUI layer is added, which provides a graphical user interface for the end user to interact with the DBMS. For the end user, the GUI is the database system, and the end user has no idea about the application layer and the DBMS systems. Okay, so it looks something like this, right? We have a DBMS, we have an application layer, we have GUI presentation layer, then we have the user client. So let me explain you what is happening over here. So you have the database. It is still there. You have the application layer as well. Which has the drivers and all. And with that, you want to provide a good presentation layer as well. Right? So that there is like a presentable and a GUI way for accessing everything. And then you basically have the user. So this presentation layer, right? So the user now just sees the presentation layer. He or she is also not aware of the fact that there is an application layer in the back also, and then the DBMS. So the user just interact with the presentation layer. Okay, they do not interact with the application layer or DBMS, and they're not even aware of the fact that there is an application layer in between. They're obviously aware that there is a DBMS system because that's where all the information isn't coming in, but they're not aware of the fact that there's an application layer in between. They interact with this application layer, which is like a good GUI, right? This is graphical user interface where everything is, let's say, present, right? You have like a navigation bar, you have like, let's say, all the tables present over here, right? This is the place where you actually, let's say, visualize the data. Here is the place, let's say, where you write the query or the language. Okay, so a good graphical user interface is provided, right? That for the end user to interact with the DBMS. Okay, here remember that when you are using applications there, it is there in tier 3 architecture, but the user does not know that it is actually there. Okay, and here what happens is, this is the one which actually understands the access language or the query language as well. Okay, like it says over here that the application layer generally understands the database access language and processes the end user request. The presentation layer is just added so that the user has a more graphical and a more presentable interface to interact with the DBMS, and it is easier for them to interact. And that is the architecture that we actually use in all the web application these days. So out of tier 1, tier 2 and tier 3 is the one that we more popularly use because it has all the things put into place, and it provides a more logical separation of concern and responsibility as well. Tier 1 has a lot of disadvantages, that it is not providing a lot of security in terms of that the user is directly accessing. So until and unless you are doing a local development or testing out the features, it's not really preferred to have tier 1. Tier 2 basically has a layer of application in between, right? It has an application layer which basically provides you all the APIs which are available for the client to interact with the database, but it does not provide any user level interface or a graphical user interface for you to interact with. Okay, but rest it's the same. Third is where you actually introduce a presentation layer in between as well, with which the people can interact. It's a good graphical user interface. It's very easy for users to interact, and they're not knowing about the fact that behind the presentation layer there is an application layer as well, right? The application layer understands the request, it processes the database access language query that you put, and it just knows and processes the request and gives you the response. And like I said, tier 3 is actually the one which is most popularly used. Okay, that quickly summarizes on what we understood in this particular video. We started with a very idea about the different users which are available, right? We have administrators, we have programmers, and we have end users. And then we talked about the 3-tier architecture. Now, based on your use case, different ways of architecture are being used to define the DBMS systems. Again, the most popular used one is tier 3 only. Okay, so this concludes our part for DBMS architecture. I hope you understand all of it. In the next video, we'll talk about the different type of database models which are actually available. And I think with that, we'll be able to conclude this very session as well. Okay. Thank you so much for attending this. Please make sure you go through the videos once again, because when you read all the slides and go through the video once again on your own, you get a better idea and you might come up with some good insights regarding this topic as well. This is very interesting. It's good to always know all these things because they provide a good perspective. And when you will design systems on your own, and when you will design, architectures for big, projects, you will have a better insights when you know all these topics in detail. All right. So thank you so much for attending this one, and I will definitely see you in the next one. Bye.